to a hypothesis test for population mean example. So our example, a study was run to determine if the average, that should say the average age of CSU students is higher than 22. It is known that the standard deviation in the age of CSU students is 4.8 years. A random sample of 50 CSU students was found to have an average age of 22.9. Can we conclude at the 5% significance level that the average age of CSU students is higher than 22? So our ultimate goal, we're trying to determine if the average age is higher than 22. So this is a yes/no research question. That means we're doing a test. We are talking about the average. And then we're just talking about CSU students. So we know we are talking about one population dealing with the mean and doing a test. Then we have, it is known that the standard deviation is 4.8 years. So anytime you see that it is known in my problem statements, that means that's the population data. So we have a population standard deviation, a sigma of 4.8. Then we have a random sample of 50 students at an average age of 22.9. So we have a random sample drawn from the entire population. We know that n is 50 and x bar, our sample average, is 22.9. Then we are asking, can we conclude at the 5% significance level? So we're looking at the 5% significance level. If that average age is higher than 22. Just a key piece of information, recall in module 23 that sometimes we work with a z distribution, sometimes we work with a t distribution. So because we know the population standard deviation, then we are free to work with a z distribution and z-score still. We do not need to work with t-score. So this was our usual step one. We are just understanding the problem. Next up, step two was the hypotheses. So we have our null hypothesis. And our alternative hypothesis. The alternative hypothesis is our research question. We want to know if the average age is less than 22, so more than 22. So the average age of CSU students is higher than 22 years. And our null hypothesis would be that it is 22 years. So the average age of CSU students is 22 years. In terms of symbols, For our null hypothesis, we're claiming that the average, so mu, equals 22. Our alternative hypothesis, we're claiming that the average, mu, is greater than 22. So again, watch your symbols. We're talking about the average here. We should use mu instead of p like we did with proportion. Step 3 is our justification. So first we want to check our good sampling technique. So we have it as random and drawn from the entire population. And then we need to check for normality of the X-bar distribution. So we have two options here. Either the population data is normal or our sample is 30 or larger. So the sample size was 50, which is 30 or larger. So we can run the test. So I'm going to call this a z-test because it's the z distribution we're working with, and then we're working with mean. So we can run a z-test for the mean because they used a good sampling technique. And the condition for normality of the X-bar distribution were met. Next up is our shape, center, and spread. So we have to understand the sampling distribution. In this case, the X-bar distribution. We need shape. We just saw in step 3 that is normal. Center. We have the mean mu sub X bar is simply equal to the population mean. And based off of our null hypothesis, we are assuming that this is 22. So again, this comes from the null hypothesis. For our spread, sigma sub X bar, we are looking at sigma divided by the square root of n, or I think it was 4.3. Let's check. 4.8 divided by the square root of 50. And if we do 4.8 divided by the square root of 50, we wind up getting 0.67 or 0.68.
Here she is. Yeah, might be better with it.
From here, we want to see how our sample fits into the distribution and to determine if it's surprising. So, see where our sample fits in. All right, see where our sample fits in the X bar distribution. So we want to see where our sample fits in the X distribution. Then we'll need to calculate the p-value, determine if our sample is surprising. So, and again, we want to see essentially, is our sample surprising? So here's our distribution. Centered at 22, this is our X bar distribution. Our sample was 22.9, if I remember correctly. Yes, so our sample mean was 22.9. And we are looking to the right because our alternative hypothesis was that the average was greater than 22. So greater than, we shade to the right. From here, we calculate z-score because we were allowed to use z in this case. So we're going to translate 22.9. Z, we have 22.9 minus 22 divided by our standard deviation of 0.68. And this winds up being approximately 1.32. So we are looking at the z distribution. Looking to the right of 1.32. From here, we should use our normal distribution calculator. And if we use our normal distribution calculator, we put in our z-score of 1.32 and enter. We are looking to the right. The right area is 0.0934. So we have the right area is our p-value. 0.0934. This is our p-value. We have 5% significance level, so our cutoff for surprising is anything under 5%. So this is 9.34%. This misses the cutoff for surprising. It is not surprising. 9.34% is not less than 5%. So from here, we can go ahead and draw our conclusion. This is step 6, draw conclusions. So our sample was not surprising. I should specify it's not surprising if H null is true. So there's no reason to doubt the null hypothesis. So you can essentially, we do not have enough evidence to conclude that the average age of CSU students is higher than 22. So notice that we have not shown that the average age is 22. We simply just do not have enough evidence to say that it is that we are convinced it is higher. So that is a hypothesis test. We were using z-score in this one. In a future video, we will do a hypothesis test where we use t-score instead.